Now for my last step in this example, I want to find the probability that the number of girls out of 10 births falls between 4 and 6 inclusive. So again, going back to my probability distribution table, when I say inclusive, that means I want to include 4 and include 6. So I want the summation of these three individual probabilities. Okay, and that's not too hard to do by hand, but I want to show you how you could use your binomial cumulative distribution function in the calculator to get the same thing. So the probability that the number of girls falls between 4 and 6 inclusive is going to be equal to the probability that x is less than or equal to 6 minus the probability x is less than or equal to 3. In other words, we're taking this entire sum of all of these probabilities and subtracting out the sum of the probabilities we don't want. And what's left over will be the sum of the probabilities we do want. Using the binomial CDF function in the calculator, I can put this in as few steps as possible. Again, going to my distribution menu, scrolling to binomial CDF. The number of births is 10. Assuming boys and girls are equally likely, the probability of success is 0.5. And my first x value that I'm stopping at is 6. Okay, so I want to find the probability x is less than or equal to 6. And then I want to subtract the probability that x is less than or equal to 3. So I can subtract, go back to my distribution menu, go back to binomial CDF, and then stop at 3 and carry it back to the home screen. So what I'm doing is I'm taking the probability x is less than or equal to 6, and I'm subtracting out the probability that x is less than or equal to 3. Okay, so I'm having the calculator do this entire sum from 0 through 6 and subtracting out the sum from 0 to 3. And then enter. And then rounding to 3 decimal places, we get 0.656. And when we did this using Minitab Express in my previous example, we got the same answer.